In this video, we will be talking about one of the most fascinating components in electrical engineering, and that is the inductor. It's a coil, which is a conductive wire wrapped around a non-conductive cylinder. What makes it unique is that it directly connects electricity and magnetism through electromagnetism induction. After many experiments and trials, Faraday, the big physicist, discovered that a changing current creates a magnetic field inside the inductor, which induces what we call an induced current. And by Lenz's law, the inductor opposes the change. It hates sudden current changes. So let's say, for example, we have an increasing current between the terminals of the inductor. We will have an induced current inside of it flowing in the opposite direction of the main current to oppose the change. In the rest of this video, I will be solving a problem containing an inductor.
First, we need to know the following informations about the inductor for the equivalent inductance of the series inductors and the parallel ones, and the expressions of V, I, P, and the magnetic energy. In this example that I created, we have a circuit consisting of 3 inductors with different inductances. We have the expression in time of I of t and the initial values at t is equal to 0 of I1 and I2. We are requested to find the equivalent inductance. We have the 30 and 50 millihenry inductors that are in series, so their equivalent will be 80 millihenry, and then this 80 millihenry is in parallel with 40 millihenry, having the equivalent inductance of the circuit equaling to 26.67 millihenries. And now we can draw the equivalent circuit consisting of the voltage V and the equivalent inductor. In the second question, we want to find the voltage V in terms of time t. We have the expression of I, which is passing through it, and the equivalent inductance. We will use the formula V of t is equal to Leq in this case, dit over dt. And we will substitute their values, and we will get the expression of Vt in millivolts because we worked with I in milliamps. In part C, we want to calculate I2 of t, the current in the 40 millihenry inductor, and then get I1 of t, the current passing through the 30 and 50 millihenry inductor. We noticed that the 40 millihenry inductor have the same voltage as V because they are in parallel. So we will use the formula I2 of t equal to 1 over L2 integration of Vt dt plus the initial value of I2, which is given as 1 milliamp. And now we know all the values in the formula, which we should substitute and get I2 in amps because we worked with the voltage in volts, and then convert it to milliamps to get rid of the powers of 10. And now we want to get I1 of t. If we get back to the circuit, we notice that we can do KCL at the top node, where we have I1 and I2 leaving and I of t entering. After writing the KCL expression, we will have I1 of t equal to I of t minus I2 of t, which are in milliamps, and get I1 in milliamps. In the final question, we want to calculate the variation of the magnetic energy in the 50 millihenry inductor from 0 to 0.3 seconds. We know that I1 of t is passing through this inductor, which we will be using in the magnetic energy expression half Li squared. In order to do so, we want I at 0 seconds, which is given, and at 0.3 seconds, which we can get by substituting t equal to 0.3 seconds in its expression. And now we calculate delta U equal to U at 0.3 seconds minus its initial value at 0 seconds. And we will use the formula half Li squared with I in amps, so we can get the energy in joules, which is equal to 9.381 times 10 to the minus 8 joules.
This one-of-a-kind behavior makes inductors really important in many engineering applications, such as car ignition systems, motors, chargers, and many more. In most cars, there exists a 12 volts power source, which is not enough to create 1,000 volts electric spark to start the engine. Therefore, there is an inductor built inside the ignition system. So when you try to start up the car, you will suddenly interrupt the current flowing from the battery to the inductor, creating 1,000 volts electromotive force, delivering an electrical spark through the spark plug, igniting the air-fuel mixture and starting the engine. Some of these informations were from denso.com and carparts.com. I hope you enjoyed this video, and I hope the intuition behind inductors is now much clearer. Thanks for watching.